Welcome everybody. In this video, I'm going to demonstrate how to evaluate this limit here. That is the limit as x approaches infinity of x to the 1 over x power. Now, I'm going to use a little trick here. So let me write an aside, but I'm not going to fill in the aside just yet. First, let's write in the trick. I'm going to rewrite this as the limit as x approaches infinity of e to the ln of x to the 1 over x power. Now, why can I do that? Well, that's because if I have e to the ln of, say, x, that's just equal to x. These two functions are each other's inverses. And when you compose a function and its inverse, you get back just whatever input you had. Well, why am I going to do this? Well, there's a particular limit law that allows me, in essence, to push my limit inside of a composition of functions. So really, I have e to the power of the limit as x approaches infinity of ln of x to the 1 over x power. And this is the part I'm interested in. So I'm going to highlight it. And let's do some side work now. And in my side work, I'm going to evaluate the limit as x approaches infinity of the natural log of x to the 1 over x power. This can be rewritten as the limit as x approaches infinity of 1 over x times the natural log of x power. And if you don't see that, or don't see how I got here, that's because if I have the natural log of a to some power, say b, I can write this as b times the natural log of a. Okay, let's continue. This is the limit as x approaches infinity of the natural log of x over x. This here is an indeterminate form. As x approaches infinity, the natural log of x approaches infinity. As x approaches infinity, this denominator here also approaches infinity. So we have the form infinity over infinity, and we need to apply L'Hopital's rule. So I have the LH here indicating that I'm applying L'Hopital's rule. And now the derivative of the top is 1 over x. The derivative of the bottom is just 1. So this limit here is 0. Now, this doesn't mean that this limit is 0. It means that the limit of the natural log of x to the 1 over x is 0. So that's this right here. And let me highlight it just to make it really clear. These are all the same. So now this here was all done in the side work. And what I end up with is e to the 0 power. And again, that 0 comes from this side work. Anything to the 0 power is just 1. Okay, so what did we figure out here? What you figured out is the limit as x approaches infinity of x to the 1 over x power is equal to 1. All right, keep calm and math on, folks. Have a good day.